Hi, my name is Henry Surediarya and welcome to ShrimpPRO demo/visual aid. Before we can start demoing the web application and also the hardware, we need to install a few things first. The first application that we need to install is called MongoDB Community Server. Simply go to mongodb.com/try/download/community. Once in the page, simply scroll down a little bit and then select the operating system that you're currently using. Download the MSI installer and you'll be good to go. The second application that we need is Visual Studio Code. Simply go to code.visualstudio.com and then click the download button. This should automatically detect your operating system and download the right one for you. But if it doesn't show up the right operating system, simply click other platforms and you'll be redirected to the download page where you can select your operating system. But we can go ahead and click download for Windows because I am running Microsoft Windows. The third application is called Node.js. Simply go to nodejs.org/en/download and click the right operating system here and also download the Windows installer.msi. Once we have downloaded all three of these applications, simply open them and follow the instructions. Since I've installed the rest of the applications, I'm going to skip the installation process. Once we install three of these applications, let's move on to the hardware side. We need to flash the firmware and also the basically necessary bin files located right here into our ESP32 to make sure that it functions the way that it was intended to be. This already includes all the code baked in, so you don't have to compile everything and then make it as one and then install it to everything. It's a hassle. This is a much faster process and it cuts so many steps that was necessary if we do it the normal way. First, open up the ESP32 flasher folder and then open up FlashTool. Select ESP32 chip and then click OK. Now, once here, we need to select all the three bin files that was located on the Do-It firmware folder. You must be warned though, before you flash an ESP32, make sure it's an ESP32 Do-It DevKit v1. Once we're sure that everything is here, simply click Start. This will start flashing your ESP32 with the firmware that I've already created. Once we have completed those steps, we can go ahead and open Visual Studio Code. Simply click File, Open Folder, open up the backend, and do the same to the front end. Once we have opened these up, simply copy or rename the .env.example and then fill them with these parameters on both backend and also front end. The first command that we need to do on both the front end and the back end is npm -i and then enter. Let's do the same here, npm -i. This will install all the required packages to run the web application. So now we're gonna wait for a little bit till it finishes. Once it has completed installing all the required packages, we can simply type npm -start. Run the same command on both front end and back end. Now if we control click this link and wait for a bit, it should open ShrimpPRO. We click login, we should be redirected to the login page. This means that the backend and front end has operated successfully. Now let's go ahead and move on to our first use case on our first iteration, login. Let's simply log in as Henry. Henry is an administrator, so we can do multiple things with that administrator account. So let's go ahead and enter henry@gmail.com with the password QWE and hit login. As we can see, we have successfully logged into the system. Now, I'm going to skip use case number 2 and go ahead and went straight through use case number 3, manage users. So, on manage users, we can add, we can delete, and we can edit users' profiles. So, Let's start by adding a user. I'm going to name this user, let's just say Bonchon. His email is bonchon@gmail.com. Password is QWE, and he is a manager. Let's add in phone number, add in address, and employee ID. Now, this is optional, but you can add a user image here. Bonchon is actually the name of my dog, so let's see if we can put a very cute image like this penguin here. Create user. User created successfully. So as you can see, we have created a user, but let's see if we can delete a user. So let's go ahead, delete Mr. John Doe. Okay, done. We can export this thing to Excel so that we have, as you can see here, we have a list of all users. And we can search Henry, whatever that we wanted. All of them can be searched. Okay, that's use case number 3 done. Let's go back to use case number 2, log out. So by hovering your mouse on your profile picture and then clicking sign out, you will be logged out. Now let's try again and enter bonchon@gmail.com because this is the user that we just created. As we can see, we have the cute penguin here, BCC018. We're logged in as Bonchon. Sign out, and let's go back to an administrator page because we need all the access here. Login. Okay, let's start use case number 4, which is manage a pond. So if we go to the pond page, there is nothing here because this is an empty database. We only imported users. Let's start by clicking add pond. Let's say it's pond A. Shrimp breed is Panamay. Administered by. Let's see. Let's just select Mr. Bonchon there. Tonnage is around 4 tons. Area is 3000. Connected ESP32 serial. Connected ESP32 passkey. Safe and minimum pH, maximum pH. So this actually crosses over to iteration 2, where we can connect an ESP32 serial and passkey and also set the minimum and maximum acceptable parameter range. I'm going to enter them here because why not? So let's enter serial 1 and passkey 1. Safe minimum pH is 5, maximum is 8, minimum temperature is 22, maximum temperature should be around 40, minimum height is 100 centimeters. Maximum height is around 160 centimeters. TDS at 300 particles per million with maximum 700 ppm. Create a pond. Now, if we click on detail here, as we can see, we have all the details that we needed. No period connected. That's for another use case. But if we go to settings, we can change the name into pond A edited. Let's just say. And then we can change whatever that we wanted. And if we click update, close, and then go back to the ponds page, we can see that it's pond A edited. Again, we can export this to Excel, but there isn't much data here, so it should be just one single pond. And of course, we can search. But there's only one pond, so you understand the point. That is use case number 4 done. Finally, the last use case is manage profile. On the first iteration, it was decided that manage profile, everyone can manage their own profile, but after giving it much more thought, we thought that it's actually a bad idea, since we do not want the managers to actually change their own information, and only administrators can do that. So in order to accomplish this task, we go back to users, click edit, and we can change their profile information. So let's just say email is notelon@gmail.com. Okay, let's also add the cute little penguin because Elon looks cute with a penguin. Update, and we can see Elon Musk A is now not Elon. He is still a manager. Same phone number. Let's update Ponchon so that he is now an admin. Done. Ponchon is now an admin, and if we try to log in as Ponchon, he is now an administrator. As we can see, now that we already have a pawn, we have the gauges already in. But we're done for iteration number 1. Moving on to iteration number 2, we have 4 use cases that we need to demo. The first one is view pawn detail. The second one is register ESP to pawn. The third one is unpair ESP from pawn. And finally, set acceptable parameter range. Now, for set acceptable parameter range and register ESP to pawn, we've done those when we added a pawn on the third use case, which is manage pawn. But there are other ways to do this exact same thing too. So there are 2 methods to accomplish this. But let's start by viewing a pawn detail. That's very easy. First, click the pawn button on the navbar, and then we have a list of pawns. Simply clicking this detail will view us all the details of this particular pawn. You can view log readings, log alerts, settings, everything that's here. Now I've added an ESP before. I've set a few datas in here, so we have a few things over here. Now let's just go ahead and skip to the use case unpair ESP from pawn. By simply clicking this button, this red button, it would unpair the ESP32 from this particular pawn. There we go. No ESP32 connected to pawn. Open settings tab to connect an ESP, which is exactly what we're gonna do. Register an ESP to pawn. Simply click settings on the sub navigation bar. Scroll down a little bit. Enter serial 1 and passkey 1. And how do we know if this actually works? So right now I have a camera open and it's right now recording the dev kit version 3.5. Within this dev kit, we can see the yellow light flashing, which means it's not really doing anything. And if we try sending data, we get a red light because it's not sending to anything. The data that's being sent is not being received by anything. So it basically informs the user with this red light. Now see what happens when I click update pawn. Immediately we have alerts flooding in. And if we go to log readings, let's change the parameters up a bit because this is a WebSocket. We have live reading. For the alerts, please do not mind that they are popping it here and there. We do have crawling, which limits alert every 1 minute, but for demonstrational purposes, I disabled set crawling. Now, how do we set the acceptable parameter range? Let's go back to settings, and then we can set the parameter range here. We can change the minimum maximum pH number. We can set whatever that we wanted here as well. So basically 2 ways to do 2 things that achieve the same goal. And if we click update pawn, there we go. Acceptable parameter range updated. That is everything that's required for iteration number 2. Moving on to iteration number 3, we have 7 different use cases, 4 of which are web related and rest are hardware related. So let's start with the web related use cases. The first one is all pawns overview. On all pawns overview, we click on overview on the navbar. We can view all the overviews of all pawns. But right now in this database, there's only 1 pawn. So let's change that real quick by changing the environment settings on the backend. I will do this off camera because this is a private database that I have, and I don't want the credentials to be leaked. So if I restart the backend, sign out, log in again, this time as henry@gmail.com because we do not have Bonchon. Now we have amazing colorful graphs here and there. So this is an overview of all ponds. Let's start from the top. So basically, if you're a manager, you can see how many ponds you're overseeing, the total pond area that you're overseeing, the tonnage that you're working with, and the different type of shrimp breeds that you're working on. Down here, we have live gauges of all the ponds. This is slide showing so that it will change automatically every few seconds, but you can pause it, or you can manually slide it to the right or to the left. Okay, this is the fun part though. Right now we can see that Ponzita has the most number of alerts. We can see the alert distribution chart, the temperature ranges between all the ponds, the pH level comparisons, the water height, basically the minimum and maximum of water height, the TDS distribution chart, critical alerts overview, and finally the top problematic ponds. What's amazing about this is we can zoom it in or zoom it out as much as we want. And that is it for overview. Wait a minute, I'm sorry I forgot. We can actually select dates for overview. So if we want to change the charts to basically, let's say from 17th to 24th December 2024, here is the real life data for such dates. But if we change it to a single pond, yes we can, but it will only show a single pond data only. So if we go to last pond, for example, it's only one pond. It's not that much of a big deal. Now, let's just move on to the next use case, which is basically view report. Here, on the overview, we see cumulative report. We can select the start end date, we can select the pond, and we can click the download report button. Let's do all ponds, then we click download report for that selected date. As we can see, instead of graphs, we have tables. Within this table, it contains all the relevant information for a shrimp farmer. So this is very, very useful if we don't want to read a chart that's basically changing every single time. So the manager or administrator can generate a report periodically to make sure that they have a logbook of basically what's going on. Because I know that many people prefer to read tables from pieces of papers. Okay, moving on to the next use case. We have view alerts. So there are multiple ways to view alert. The first one is we can view the last alert that was received. So as we can see, there's a critical alert for last pond. But if we start sending bogus data to trigger an alert, there we go. We receive an alert toast. So this thing will pop. It doesn't matter where you are. It will pop. There. Now, I do have crawling as I mentioned before, but I deactivated it for this basically demonstrational purposes. Okay, so let's stop this thing. And then try to view the complete log of alerts. So how to do that? Basically click on pond, click the pond detail of a pond, and then here, click on log alert. It will parse the data first, so please be patient. And here we have a complete log of all alerts. We can search for a specific alert. So for example, I want to know TDS alerts. So now it will sort everything. It will sort the table to only show alerts that includes TDS as an alert point. You can also use pagination. And yep, that works. And finally, we can export this to Excel. There we have a complete log alert. Finally, the final use case that is web related is manage period. So a period is a time frame in which a pond is filled with shrimps. There are times that the pond is being clean, there are no shrimps in it. So this is very useful for a shrimp farmer. So first we add a period, let's say a new period, Select a start date, maybe 21st of December 2024. Sounds good. So we create a period. Once we create a period, it will automatically become an active period. We can end set active period by clicking this, and we can restart a period by clicking the start period. If you do not want to search for which one is the active period, you can click stop all periods to basically stop the currently active period. You can search by name and also use pagination if there are more than 10 of these. Finally, we can delete a period. So for example, I want to delete this. I'm sorry, there's one more thing that I missed, is edit period. So basically we can edit any period that we want, change the name, whatever we want, change the period end date, click update, and that's it. We are done. And that is everything on the web related use cases. To the hardware side of this iteration, we have 3 use cases left. The use cases are manage ESP32 Wi-Fi, calibrate sensors, and finally ESP32 input selection. Let's first start by managing the ESP32 Wi-Fi. So right now I'm using the ShrimpPRO DevKit V4 because it has the directional pad and also the OLED. And once we're in the main menu, what we need to do is use the D-pad to navigate, select options, go to Wi-Fi options on the options submenu, and then finally hit open Wi-Fi portal. Once we open the Wi-Fi portal, we can move to our laptop and then connect to the ESP32 Wi-Fi portal with the credentials that is noted on the screen. Then we go into the web manager app, which is 192.168.4.1, then click configure Wi-Fi. Once it's done searching, we can enter the network SSID and also the password. Once we're done, click save. Wait for a little while. Click the left button twice, and there we go. Back on the main menu, we can see we have an SSID, and we have the IP address, the IPv4 of this particular ESP32. Now, what if we want to change the API address? We go back to Wi-Fi options. We open the Wi-Fi portal again. If it's accidentally closed, we connect to it on our laptop. We reopen this. We click on setup, and then we change the API address. In this case, I want it to be .100 because it's my computer. Save. Now, if we go back and we go to the post settings, as you can see, it is now 192.168.1.100, which matches up to what I entered on my laptop. Okay, next use case. The next use case is calibrate sensors. To do this, we go back to the options submenu, select calibrate. Let's start with calibrating height. Now, let me grab my camera and then start recording. So this is the height sensor. As you can see, it's suspended on this little frame. How this thing calculates the height is it sends an ultrasonic sensor and then it calculates based on the distance and based on how long that ultrasonic bounces back to the sensor, the distance between that object underneath and also the sensor itself. So right now it's at 75.7 centimeters. I'm just going to click save height. And then there we go. Height is already saved. One click calibration for height. For pH, it's slightly more harder to do because we need 250 milliliters of water. And then we also need these things. These are called pH buffers. So if mixed with 200 millimeters of basically pH 7 water, you can get pH level of 4.01, 6.86, and 9.18. And what happened is, as you can see there, there's a voltage reading on that probe. Once this water is mixed with the buffer, we simply insert the pH probe into the bottle, and then it will change the voltages based on whatever pH this is. So for example, if we put a pH buffer of 4, we note down the voltages there. Maybe it's 1.1 something. If it's 7, it should be around 1.6. If it's pH 9, it should be around 1.8, 1.9. Once the user note that down, we go back twice. We go to Wi-Fi options. We reopen the Wi-Fi portal. And once we're back in the portal, we need to wait till we can connect to it. Okay, so this is one of the bugs that I noticed existed. Sometimes we need to restart this to reopen the Wi-Fi portal. This happens because I'm using a library that is still not fully developed yet. But that is okay, since we can now reopen the Wi-Fi options, reopen the Wi-Fi portal, and we should be able to connect soon. ESP32 portal. Reopen this. We click on setup, and then we enter the different pH, different voltages at the different pH levels. So right now, let's change it to 0.96, 1.65 should be the middle ground, 2.12, and then pH calibration offset, basically how far it is even after it's calibrated. If it's still off, you can enter an offset here. And then finally, we can also change the empty height right here. But we're not going to do that since we already automatically calibrated it previously. So we click save. And just like that, everything should be calibrated. Moving on to the final use case, it's ESP32 input selection. We select input on the main menu. By simply clicking the up and down arrow key, we can change from sensors to potentiometers. Before it was reading from sensors, let's change it to potentiometers. So if we go to reading, it will say simulated reading. We can turn the knobs and change the values. But if we go back here and then we switch back to sensors, left is for back, by the way. Click on reading, it's no longer simulated, and we can also calibrate the pH level here. So if we click this, it would change the pH to pH voltage. Click post, we can start sending post requests to our backend server. That is everything. Thank you.